Okay, let's take a look. We have the expression negative 5y plus 10. Click those Chromebooks all the way closed, please. Let's see here. Peter, what's the variable in that expression? It's y. I agree. It's y. What's the coefficient, Michaela? Negative 5. Everybody, what's the constant? 10. Okay, take a look at that real quick. Get your bearings. Get your bearings. Okay, we want to write this as an algebraic expression using x to represent the unknown number. Let's see. Peyton, what do you think? Twice the sum of a number and 8. It's a little tricky. How would I say the sum of a number and 8? The sum is plus, good. So what plus what then? We said that we're using x to represent the unknown number. X plus 8, I like it. So that's x plus 8. Now, how would I do twice that whole sum? What do you think? Yes, sir. Put a 2 out here. Okay, there's the other part. I need to close the whole thing in parentheses, don't I? Because I'm taking 2 times that entire sum, not just 2 times the x, it's 2 times the whole sum. Okay, give me thumbs on that. How we doing? All right, good. Okay, so just quick review. Sets of real numbers. All numbers are real numbers, right? Every number you know is a real number, but those can be broken down into subsets. All real numbers either fall into the category of rational numbers, which are numbers that can be written as a fraction of integers, right? Or irrational numbers, which are numbers that cannot be written as a fraction of integers. And then remember that the rational numbers also contain some special subsets, and the only one we're concerned about at this point is the set of integers, which are all the fractions, positive and negative, with a 1 on the bottom. So the positive and negative whole numbers, right? And then the other thing about that is irrational numbers. If we write them as fractions, like pi, for example, they're going to be random decimals that never terminate and never repeat. They just go on forever, create some crazy no pattern. Rational numbers, if we write them as decimals, always do one of what 2 things? If I write a rational number as a decimal, it's either going to do this or this. What are those options? Pick a really simple example, like 1/2. What's 1/2 as a decimal? 0.5. Now, what kind of decimal is that if it stops? That's terminating, right? So a terminating decimal is one that stops. What about 1/3? What is that as a decimal? 0.3 repeating. So there's 2 possibilities. Rational numbers, when written as a decimal, will always either repeat or terminate. Okay? All right, so now let's just practice putting sets, or describing sets. So the one on the left. Look at that set. What does the ... mean, by the way? Goes on forever. Okay. So then what's the set that best describes that? Integers. Everybody agree? Integers, yeah. All the positive and negative whole numbers, right? Okay, so that's integers. I like it. Okay, now what about this on this other side? First of all, how do we even read that? This is set builder notation. Remind me how that works. What does that first part mean? How do I say that? Might have a little reviewing to do. You got some time, but you got a little reviewing to do maybe. Remember, that's the set of all x is what that first part tells us. Set builder notation always starts off telling us what set are we talking about. In this case, it's the set of all x How about that vertical bar? What does that mean? What are the words that that represents? It's not an operation. It's not an absolute value thing. It just represents some words. Such that, remember that? The set of all x such that, and then the rest of it. X is rational or x is irrational. Well, which number set best describes that? The set of all x such that x is rational or irrational. Contains both. What's the only answer here that makes sense for us? What's the only set that contains all the rationals and the irrationals? Whole numbers have to be real numbers, wouldn't it? The whole numbers wouldn't work because whole numbers are a subset, and they're a subset of rational numbers, right? They don't even contain all the rational numbers, right? They just contain some of them, but they don't contain any of the irrationals. The only one that works is the set of real numbers. That's the set of all the rationals and the irrationals combined. That's everything. All numbers are either rational or irrational. So it has to be the set of real numbers. Give me thumbs on that. Okay, this is clearly, and I get it, this is the part that you probably need to review, because this is the part that we don't do very much, right? This is just kind of some concepts and vocabulary that we covered. We haven't really talked much about it since then, and we won't. We'll come back to it every once in a while. But when we're doing algebra stuff, we're not really dealing with this very often, right? So you definitely need to go back and review this stuff, though, from the early in chapter 1. Okay, now this is probably getting a little more comfortable. Now we're getting into more algebra-like stuff, right? So simplify the expression. This is just PEMDAS. So when you're doing this on a test, I would always write down PEMDAS so you have something to stare at, right? P, E, M, D go together, A, S go together. So what's first here? Parentheses. I completely agree. Parentheses are first. So what can I do inside the parentheses? And that is, good. Okay, so there's step 1. What's step 2? Exponent. Okay, so what does that mean? What am I, by simplifying exponents, what am I doing here? Oh, whoops. Your good question. Why did I? That's supposed to be a 4, isn't it? Thank you. That's a little better, okay? So exponents are next. That's step 2. And what does that mean here? Negative 2 to the 4th. So what is that? What is that stuff equal to? What is negative 2 to the 4th? Okay, so negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times another negative 2 is positive 16. In general, remind me, a negative number to an even power is always positive. A negative number to an odd power is always negative. Good. Okay, so the next step then, this is equal to 4 times 16. Last step, multiply. 4 times 16 is 64. That's it. Okay, give me thumbs. How we doing? Okay, that's better. Pretty clear. The stuff that you're probably gonna have to review the most is go back a little bit, right? How about this one? A little bit more going on here. Okay, so I've got brackets and parentheses here. Which one am I gonna, I've got 2 layers of grouping symbols. Which one do I do first? Inside, so parentheses would be first, wouldn't they? Okay, so step 1 is parentheses. What does the first set of parentheses simplify to? Second set of parentheses. And then I got a plus sign. What's next? Brackets. Okay, so brackets are step 2. Well, what is 1 plus negative 10? Negative 9. And I'm just going to make those parentheses instead of brackets. So I get 5 minus negative 9. What's next? No exponents. No multiplication. So it would be either addition or subtraction, whatever you want to call it, right? What is 5 minus negative 9? Done. Okay? Good? Okay, so that was a simplify problem. Another simplify. Now, what about this one? When you see something like this, where I've got a great big fraction bar with lots of stuff on the top and lots of stuff on the bottom, how do I organize my thinking about this? What am I going to do? Well, I mean, eventually, but okay, good. I'm going to simplify the top by itself, bottom by itself separately, and then what's going to be the very last step? Divide. Yeah, I got it first. I've got to work on the top separately from the bottom. So what do I do on the top first? Okay, so the first thing I'm going to do on the top is multiplication. 1/2 times 4, that's just 2, isn't it? How about on the bottom? What's the first thing I do? 1/3 times 9 is 3. So I get 4, whoops. 4 plus 3. Okay, now what? Now top. What's next? What did I not do? Did I forget something? Okay, does that make sense? Okay. Okay, so then on the top, what do we get? -3 on the bottom, I get. And can I simplify that quotient? No. So my answer is just -3/7. Done. Okay? Good? All right, so this one's a little bit different, but not much. When you see something like this where it tells you to evaluate, what are you immediately thinking about? What's evaluate always mean? Well, maybe it might involve all kinds of operations, but there's always something that you're going to do in a problem where you're asked to evaluate. What is it? Okay, eventually, but we're not to the simplify stage yet. What's the first thing, Peter? Okay, so it's going to be a plug-in problem, isn't it? Evaluate always means plug in. And this is an evaluated expression ends up always being a plug and chug problem. You're going to plug in values and then you're going to chug through some algebra to simplify it every time, right? So first step though is plug in values. So every place where I have an x, I'm going to substitute a 9. Every place where I have a y, I'm going to substitute a -3. So on the top we just get 3 plus the absolute value of x, so I'm going to plug in a 9. When I'm plugging stuff in, what do I always have to remember to include? Okay. Parentheses. Always include parentheses. So that 9, I'm going to put inside parentheses. In this case, putting the 9 in parentheses didn't really... Oh, it does. You're right. Sorry. Man, you guys got to watch me like a hawk today, don't you? Okay. So what used to be an x now becomes a 9. The parentheses didn't really do much there, but that's okay. They don't hurt anything. Minus y. And again, what do I have to put that in? And in this case, I really need those parentheses, don't I? Because I'm subtracting a negative, and otherwise it wouldn't look right. Okay? So always substitute things, numbers in parentheses. On the bottom, we've got an x, so a 9, plus 2 times y, so a negative 3, both in parentheses. Yes, yes, take a pass. Okay, good. So we made our substitutions. Now we just have to, it looks just like the last problem, we just have to simplify this. So we've got the top, we're going to simplify separate from the bottom. What do I do first on the top? So which step would that be in PEMDAS? What's the first step in the numerator? Parentheses. Even though they're not parentheses, remember parentheses really means all grouping symbols, right? Anything that groups stuff. So what is grouping stuff on the top? The absolute value bars. Yeah, so we have to simplify everything inside there, don't we? So on the top, that's going to equal 3 plus 2 times the absolute value of 12. Right? On the bottom, we'll do one step on the bottom also. What's the first step on the bottom? Multiply. Yeah, so on the bottom, we just get 9 plus 2 times negative 3 is negative 6, right? Okay, what is the absolute value of 12? 12. So we could just replace that absolute value of 12 with a 12, right? On the bottom, we're pretty much done. What's 9 plus negative 6? 3. We're not quite done on the top, though. What's next on the top? Multiplication. So 3 plus 24. And then finally, what do I get for my quotient? What's on the top? Divided by 3, which simplifies to what? 9. There it is. Okay? Good? Okay. Okay, just some more vocabulary stuff. What's the opposite of negative 9/10? Positive 9/10. What would the opposite of positive 7 be? Okay, good. What's the reciprocal of negative 9/10? Negative 10/9. I'm just going to flip the fraction. So here's one common mistake with that. Sometimes people try to do too much. Sometimes people try to make that positive, but it's not. The reciprocal of a negative number stays negative. The reciprocal of a positive number stays positive. All you do is flip the fraction. You don't change the sign, right? So that would just be negative 10/9. Okay, let's do a very quick review of our properties of real numbers. Been a little while. And again, this is something that we don't use all the time, so this is probably the stuff, even though it's the easiest stuff, it's probably the stuff you need to review the most, I bet. The commutative properties of addition and multiplication. Remember, to commute means to exchange. So the commutative properties just say A plus B equals B plus A, and A times B equals B times A. The associative, remember, the commutative property involves two things whose places are being switched. The associative property involves more than two things, so 3 or more things. To associate means to group. This just says when I'm adding up a bunch of stuff, I can choose the order in which I group those, right? Because I have to add things in pairs. So for example, if I have 3 numbers, A plus B plus C, I could group the B plus C first and then add A, or I could group the A plus B first and then add C. Same for multiplication. If I'm multiplying more than 2 things, I can choose the order in which I group those. Okay? Distributive property, you all know. That one we can skip through. Then we've got the I properties that go together, identity and inverse. Identity is easy to remember because the identity properties are the ones where the identity of what you start with doesn't change. I start with an A, I end with an A. How do I do that? Well, A plus 0 equals what I started with, A. There's the identity property of addition. A times 1 equals what I started with. So there's the identity property of multiplication. And the inverse properties are the ones that go with the identity properties, because whatever that special identity number was that I either added or multiplied by to keep something the same, in the inverse property, we ask ourselves, what could I add to a number to get back that 0? Opposite, right? So the inverse property of addition says A plus its opposite, negative A, equals 0. For the inverse property for multiplication, again, we want to get back that special identity number for multiplication, which was 1. A times what equals 1? Its reciprocal. So there's the inverse property of multiplication. A times its reciprocal equals 1. So now let's practice using these things. So you guys tell me, look at these real quick. Look at that first one. 3b times 1 equals 3b. So what property is that going to be? And I'll give you a little hint. I think the important part of this one is that part. Okay? What do you think? Eliza, what's that one going to be? 3b times 1 equals 3b. Okay, that's it. Okay, it's the one where they're the same. What do we call that one, everybody? Identity property of addition or multiplication? Multiplication. Good. Okay. 4 times 3 equals 3 times 4. What do you think about that one, Jubal? Okay, so it's the one where we're exchanging places. What's our math word for that? Commutative. There you go. Commutative property of multiplication. All right, I like it. 6x times 1 over 6x equals 1. And this is, I would say, the giveaway right there. Inverse property of multiplication. Okay. Now this time, I'd say the giveaway is there's more than 2 things, right? Let's see. So 8 plus the quantity x plus 7 equals the quantity 8 plus x plus 7. Bavis, what do you think? Which one's that going to be? Which is the one that deals with more than 2 things? Remember that one? Okay. Help them out, somebody. What do you think? Yeah. Associative. And to associate means to group, right? Good. So the associative property of what? Looks like addition, right? We're adding stuff. Okay. 9 plus z equals z plus 9. What do you think about that one? What is it? Commutative property. I agree. I like that. Commutative property. Okay? Okay, Trent, what's the next one? We're used to that one, right? We see that one all the time. What is that one? Distributive property, sure. Distributive property. There we go. 0 plus 9 equals 9. Aiden, what do you think? Identity property of addition. Good. Okay, look at that next one. The quantity 6 times y times 5 equals 6 times the quantity y times 5. What do you think? How about that one? Garion, what do you think that one is? Associative property of multiplication. I agree with you. And then finally, 8 plus negative 8 equals 0. And the equals 0 is kind of a key one there. Avery, what do you think? Very close. It's the one that goes with it. Inverse property. There you go. Good. Inverse property of addition. Good job. Okay. All right. So now, there we go. Okay, let's just practice making some conversions from words into symbols for inequalities and equations. How about this top one? Twice x plus 5 is the same as negative 7. Well, how do I say, what's twice x? 2x plus 5 is the same as negative 7. All right, good. Okay, the quotient of n and 3, what's that? What's quotient mean? Division. So n divided by 3 is, what's is? Equals 5n. All right, 5 times n, I like it. The product of 8 and x, 8 times x, is less than or equal to. Yeah, so which way is that opening? Okay, like that, right? Good. It's less than or equal to negative 14. All right. Okay, this one's a little tricky. Twice the difference of x and 6. Well, how do I say the difference of x and 6? Oops. How do I say twice that whole thing? There you go. So I'd need 2 times the quantity x minus 6 is, so equals negative 22. Good. Okay. So we're just doing some simplifying. Now I want to point something out here. Am I going to end up with a number answer on this one? Thumbs up or down? Yeah, am I going to get like C equals something? No. No. Because, how come? Because the question does not ask me to solve, it asks me to simplify, right? So always read these carefully. Sometimes I think people get off on the wrong track because they just assume they're doing a problem that's different than the one that's being asked. This is not a solve problem. This is easier than that. It's just a simplify problem. We're just trying to write this in a simpler, more condensed form, right? So what do I do first? Okay, so inside the parentheses, I can't really do anything. 5 minus 3c, I'm stuck with. But I could distribute, so I'm going to multiply first. Agreed? There's my first step. So multiply. What am I distributing this time? Negative 1. Good, and we can think about that as even just distributing the negative. So what's that give me? If I distribute the negative to the 5, I get negative 5 plus 3c, and then out in front I've got a negative 9c. What's my last step? Combine like terms. Good. So there's step 2. So what's negative 9c plus 3c? Negative 6c minus 5, and then I'm done, right? Question? Yeah, you bet. Take a pass. Okay, how about this one on the bottom? Okay, good. The first thing I would do is distribute because there's nothing in parentheses to simplify. There is an exponent, but it's nothing I can simplify, right? Just attached to a variable. So the first thing would just be to distribute the negative 3. What's that going to give me? And then the rest is just going to stay the same, isn't it? Minus 5yz plus 1 plus y squared. What's next? Okay, so it looks like I've got, yeah, negative 3yz's minus 5yz's is negative 6 plus 1 is good. And then finally, there's just a plus y squared. The y squared is kind of the lone wolf here. It's not, there's nothing to pair it with, so it stays the same, right? There are no other like terms. Okay, this is different. Now, what am I going to do in this question? What are they asking me to do? Solve. Okay, so this time I am actually going to come up with a number solution, presumably, right, for y. Okay, can I just jump right in and isolate y? No, how come? I can't point to a single y, right? I can't point to a single variable, so I have to simplify first. What's that mean? Distribute. Okay, and I'm going to, what am I distributing in the second case? The negative 2. So that's going to give me, over here I've got my 5y plus what? Minus 8, I like it, equals 7y plus, negative times negative is positive. Good. Now what? Combine like terms. Over here I've got, there's some like terms, 5y plus 2y. How about over here? Okay, now what? Where do the variables go? Which direction? Point, everybody. Good, we want to move them to the left, don't we? So we're going to subtract 5y. And then what else could I do maybe at the same time? Good. Push the constants the other way. Yeah, so we get 2y equals 28. So y equals, okay, on the test, what should I definitely do here before I submit my answer and go to the next one? Check it. Yeah, and how am I going to check it? Desmos. You have Desmos. So let's quickly kind of remind ourselves how that works. Okay, so first of all, there's my original equation. What am I going to do? Okay, I'm going to, but what I have to write that left side using what kind of notation? Yeah, but I got to set that, I have to be able to plug in my value to see if it works. Okay, so I'm going to use function notation. Yeah. So I'm going to write this using an f on the left side, right? So f of my variable is a y. So I'll do f of y. You could just make those x's if you wanted to. It's fine. F of y equals whatever's on the left side. Don't change anything. Go to the very first step. And so all the stuff on the left side, 5y plus 2 times the quantity y minus 4. Just make it look exactly like the original left side of the equation. What about the right side? G of y. Good. G of y equals whatever's on the right side. So that's 7y minus 2 times the quantity. So just open up a set of parentheses. Y minus 10. Okay, now how do I use this to check the solution? Okay, I'm gonna plug the 14 in for y, so I'm gonna get f of 14 gives me 90, and g of 14 gives me 90. So what does that mean? We got it right. Before we even plug it in, we know that we have the right answer, which is a good thing. Okay, for our notes, We know it's correct. Okay, how about this one? Can I point to a single x? Got to simplify, so what do I do? Distribute 3x plus 15 plus 7. Oh, okay, we'll pick the rest up tomorrow. Review real quick. Our test is going to be a week from today, right? So you have a little bit of time. The review assignment is up. It's required. It's the most important assignment of the unit because it just everything that's on the test is on the review. Okay, we left off here. We just have a few more to do. What do we do if I have an equation like this that we need to solve that involves a bunch of equations or a bunch of fractions? What do you think? Okay, good. We're going to clear fractions by distributing the LCD, right? So what is the LCD? Right? It's the least common denominator. In this case, what number is it? 35. How'd you get that? You're right. Yeah. Oh, you did? I thought you did. Who said? Okay. Well, somebody tell me, why is it 35? Okay, because it's the smallest number that all the denominators divide into, right? Okay. So it's 35. I'm going to distribute that through both sides. So I'm just going to put the whole thing in brackets and distribute to 35. Now, what was our process for doing this that made it so simple? When I distribute it to that first term, what do? Divide first, right? I'm going to reduce the fraction first. 35 over 7 crosses out the denominator and reduces to 5, which gets multiplied. The denominator's gone, so it just gets multiplied by the top, right? So I just get 5x. Next term, 7. Cross out the denominator, 35 over 5 reduces to 7. Multiplied by the top just gives me 7x. On the other side, 35 over 7 reduces to 5 times 9 is 45. So we still haven't solved the equation, but we traded that ugly fraction-filled equation for one that's got no fractions, so much easier, right? Combine like terms, good. I still can't point to a single x, but if I combine the like terms, I get 12x equals 45. Last step, divide. Divide each side by 12. And so I get x equals 45 twelfths. Is that fully simplified? No, I can reduce that fraction, can't I? What's a number that goes into both the numerator and the denominator? 3. So I could divide both by 3. 45 divided by 3 is 15. 12 divided by 3 is 4. And then I'm done, right? 15 over 5 can't be reduced anymore, so that's my solution, okay? How could I check it? Plug it back in. And here's a case where it really helps because my original equation had a whole bunch of fractions in it, and so it'd be kind of ugly to plug that in without using Desmos. Now on the right side, I already have a number, it's 9/7. So I don't even have to plug anything into the right side. I just have to see if the left side gives me 9/7 when I plug in my solution. So let's try that real quick. If I pull up Desmos Scientific, which again, you get on the test, so make sure you know how to use it. All I have to do is just make a function for the left side. What am I going to call that function? F of x, good. And it equals exactly what I started with on the left side. So x over 7 plus x over 5. And then I'll just plug in my solution and see if it works. How do I do that? F of, good, 15 fourths. And uh-oh, how do I know? That doesn't look like 9/7. What do I have to do? Click the fraction button. There you go. Okay, and what do you know? It's 9/7. So that tells me that it is a valid solution. Okay. So checks, it's a solution. Okay, give me thumbs. How are we doing? Is that all good? Okay, how about one like this? So they give me a rectangle, and it says write the following as an algebraic expression and then simplify. The perimeter of the rectangle with length w plus 3 and width w. Okay, so if we're going to call that the length and this the width. So the length is the red edge, the width is the blue side of that. How could I write an expression for perimeter? How many lengths are there? 2, right? I've got 2 red sections. And how many widths are there? 2. So then the perimeter would equal what? Okay. Good. I get 2 of those, 2w plus 3s plus 2 x's, and I could simplify that. Right? They want to write it in simplified form. It says then simplify. So I could just distribute the 2 and get 2w plus, or 2x, sorry, that's not supposed to be a w. Oh no, it is supposed to be a w. This is supposed to be 2w, isn't it? So I get 2w plus 6 plus 2w, combined like terms. There you go. Okay, make sense? Okay. By the way, this is not an equation, it's an expression, so we're not going to have an equal sign, right? That's our answer. We're done. Okay, compare that to this one. This says use the diagram to find the angle measures of the triangle. And it gives us a hint. Recall that the sum of the angle measures of a triangle, they all add up to 180. So this time they're telling me to find something. So I'm going to have an equation here because I have to solve. I got to find values. Agreed? So I know I've got to come up with an equation. So what would my equation be? Tells me that angle is x degrees, that one is x plus 6 degrees, and that one is 4x degrees. Add them all up to equal 180. There you go, right? So we're going to get x plus 6 plus 4x equals 180. Good. Now I've got an equation. I can just solve it. If I combine like terms, how many x's do I have total? 6. X plus 4x. 6x plus 6 equals 180. What would my last 2 steps in order be to solve for x? Subtract 6 and then divide by 6. Good. So 6x would equal 174. If I divide by 6, that's going to give me x equals, well, 6 goes into 17 how many times? Twice, with how many left over? 5. 6 goes into 54 how many times? 9. So x equals 29. Am I done? Just solve for x. Am I done? Okay, I got to plug those back in. So that means this angle is x, so that's going to be 29 degrees. This one is 4x, so that's going to be 4 times 29, right? So what's that? Well, what would 4 times 30 be? 120, right? So 4 times 19 must be 4 less than that, because instead of 20 4s, I've only got 19 4s, right? 116. And then x plus 6, well, 29 plus 6 would just be 35. Whoops, that doesn't look like 35, does it? Okay, and we could check those. Okay, what do you know? We got them. Okay? How could I do a real quick check on this just to see if I think I got it right? Add them up. They should add up to 180. Yeah. Okay. The perimeter of this triangle is 320 feet. Find the length of each side. What could I do? It says find the length of each side. So is this going to be, am I going to write down an expression or do I need to come up with an equation? I need an equation because I have to find something. Okay, what would my equation be? Add them all up and they should add up to 320. You betcha. Okay, so 5x plus x plus 8x minus 2 equals 320, and it's the same thing, isn't it? I'm just going to solve this thing. If I combine like terms, 6x plus 8x is 14x minus 2 equals 320. Last two steps, everybody? Add 2, divide by 14. So 14x equals 322. If I divide by 14, what's that going to give me? 14 doesn't go into 3, but it goes into 32. How many times? Twice. With how many left over? 4. Okay, and 14 goes into 42 3 times, yeah. So x is 23, so then I could just plug that in, right? That's going to give me 23 on that side. 5 times 23 is what? What's 5 times 20? There you go, 100. Plus 5 times 3 would give us 115. How about 8 times 23 minus 2? Well, what's 8 times 20 would be 160. 8 times 3 would be, so 160 plus 24, 184 minus 2, 182. See, you can do all that stuff in your head. Okay, good? Give me thumbs. How we doing? Okay. Last one, very simple. How many variables in that equation? How many? 4 total, right? It wants me to solve for the variable w. So I'm just isolating w. I can do it in one step. What is it? Yeah, divide both sides by LH. Now they have to be capital, remember, because variables are case sensitive. So if you didn't write these as capitals, you'd get it wrong. So I get w by itself equals v over LH. Make sense? All right. Thus ends our review. Okay, I got one more thing for you today, though. Tomorrow you get to work.